This is for mathematical methods. It comes out of the VCAA 2019 exam 2, question number 3. So what do we have here? During a telephone call, the phone uses dual tone frequency to communicate. Okay, so the strength, so this is strength against time, and we have the addition of these two sine functions. So I've got that over here, and I might just bring it up onto the screen just to make sure that everything there matches. So I'm going to go from 0 across to 24, and I'm going to go up to 2. And that makes sense. Okay, find the period of the function. Well, it looks as if up to here is one cycle, and then that repeats itself up to there. So I'm comfortable to say that the period is 12. The other way that I can find the period is the period of this one is 2 pi divided by pi on 3, which is 6. And this one is 2 pi divided by pi on 6, which is 12, which means that this will have cycles every 6, 12, 18, 24. This one will have cycles every 12, 24, 36. And you can see that 12 is the overlap of each of them completing a complete cycle. So 12. Find the values of t where f of t equals 0 within this interval. Looking at the graph, I think there's 1, 2, 3 times. So t equals 0, 4, or 6. I can confirm that by setting that equal to 0, but because it's involving signs, I'm going to put in a restricted domain where I'm going to go from 0 inclusive, x inclusive to 6, and solve for x. And because I put in the domain, it gave me the 3 answers I was looking for, but the graph also indicated the same 3 answers. Find the maximum strength of the dual tone frequency to 2 decimal places. That looks as if it's going to be that value there. So if it's to do to 2 decimal places, so I can do analysis G solve max. That was F min. So how about I do that again? Analysis G solve max. And the maximum value is 1.7601. So 1.76017, which is 1.76. Now, be careful, it's asking for the maximum, not the x value that it occurs, which is the different value. And lastly, find the area of the graph between 0 to 6. Between 0 to 6, I'm wanting that plus that. So I need 2 definite integrals. So it's 2 marks. So I'm going to write the integral from 0 to 4 of, it's called f of t dt, plus, instead of 4 to 6, 6 to 4 of f of t dt. So that will give me my 1 method mark. And I'll come up over here and I'll do that because I need a definite exact answer. So I'm going to go from 0 to 4. And then I'm going to go from 6 to 4, which will turn it into a positive answer. And I'm going to add those two together, which gives me 15 on pi units squared. Okay. Now we have g, and it's a function that has some form of transformation. I've got to come up with find values of a, b, c, and d. Now there are lots and lots of answers for this. I'm going to come up with but one. Now I know that if I integrate from g of t from 2 to 0, notice that the terminals have been flipped around, plus 2 to 6 of g of t, I'm going to get the same area as I got in the last answer. Now, I've got some reflections and translations happening here. So notice that the smaller one would be down here. So, and the smaller one is from 0 to 2, and the larger one is from 2 to 6. So I'm thinking if I reflected this over the y-axis, then it would look like that. And this value over here would be -6, -4. And then if I move everything to the right 6 units, then I would end up with that looking like this. And that makes sense that I'm going from 2 to 0, which will give you this area here but turn it into positive, and 2 to 6. So I'll just confirm that. What I might like to do is I might like to copy that, put it into a new line, and I'm going to define it. Now, I wish to reflect over the y-axis, therefore I'm going to have f of -x, and I'm going to translate right 6 units. So f of minus x minus 6. Minus bracket x minus 6, close bracket, close bracket. And if I graph that on here, I wish to see exactly that. So what does that mean? If I'm reflecting over the y-axis, A has to equal -1. I'm not reflecting over the x-axis, so therefore B is going to equal 1. I'm translating 6 units to the right, so C has to equal 6, and I don't wish to move upside down at all, so D equals 0. Okay, and lucky last question. The rectangle bound by the line of K and 12, so that's equal to 12K, equals the same area as F, so I'm back over to F, horizontal axis for one period. Okay, I know that that was 15 pi, but that's only half a period. So for one period, there's going to be another 15 pi, so it's going to be 30 on pi, because this was 15 on pi. So 12K equals 30 on pi. K is going to equal 30 on pi divided by 12. K is going to equal 6 goes to that 12 goes to that 5. 5 on 2 pi.